Hello everyone, this is a little lecture about the common array fun in MATLAB. So suppose that we have a vector in MATLAB like values from 1 to 8, and suppose that we want to apply a certain function to it, right? So for example, we want to apply the function cosine t minus t square. So we want to calculate cosine t minus t square for each value of it. So if I write it like this, then it's going to give me an error because t square is a matrix operation, and it is inconsistent with the matrix size. Well, but what if I want to calculate like cosine 1 minus 1 square, then cosine 2 minus 2 square, cosine 3 minus 3 square, and so on, right? So I want to do this for each entry of the vector. Then the direct way that we've learned I'm sure you've learned it in the first semester, and we reviewed it in week 1, is to do this. So cosine t minus t square, but the square operation is going to be the pointwise operation, right? So then it's going to do the job. Well, but suppose that I have another vector like v is, let me just give you some random numbers, like let me do this, say rand 10 times once 10. And so what if I want to do this to every entry of the vector v? So then I will have to write cosine v minus v square. So this would be the same thing as to write cosine of v1 minus v1 square. So now I'm going to get minus 29.444, and cosine v2 minus v2 square, and so on, right? That's the same thing. So now arrayfun is a more powerful alternative to this. So let me show you how it works. So when I want to do arrayfun, I'm going to write arrayfun, and here I'm introducing a function of, say, I don't know, x, that takes x as an input, and its output is going to be cosine x minus x square. Now this is without the dot, because this is supposed to be a function from a number to a number, from a scalar to a scalar, and I'm going to apply it to each entry of the vector t. That's the output. Or I can apply it to each entry of the vector v. That's the output. Now, why do I want to do this? So why do I want to use arrayfun when just the expression is going to be so much simpler? The reason is because not every function can be written as a simple expression. So let me give you an example. Yeah, so suppose that what I want to do is, so given a number x, let's say x is, I don't know, 6.7. What I want to do, I want to say create a matrix where on right above the main diagonal I have 1. Then I'm going to put x on the main diagonal, and I am going to put -1 below the also ones below the main diagonal. So I'm going to write it like this: so once 4 1 diagonal of -1. Okay. Well, for every number x, I can create such a matrix. And then suppose that I want to calculate the determinant of this matrix. So I'm going to, so let me write that, denote this by A. And then I want to calculate the determinant of A. my point being is that this is a complicated function that you cannot really express as a single expression. I mean, you can, but it's just too huge, right? So this operation, creating a matrix and calculating its determinant, it can be, I mean, if you want to apply this operation to every entry of a certain vector, then you can use arrayfun to do it. So here is how. You can write arrayfun, then the function of x is going to do this, right? It is going to, let me just copy this whole thing, Control C, and right, this is going to be the determinant of this whole thing. And then I'm going to apply it to, say, the vector t. Now it works. So for every entry of the vector t, it calculated this expression. Or, I don't know, if you want to apply it to every entry of the vector b, you can. So for each entry of the vector v, it created this matrix with ones above diagonal, ones below diagonal, and number x on the main diagonal. The matrix is 5 by 5, and it calculates its determinant. But now, you can actually simplify it, because what's going on here, when you do this, you actually introduce a little function that you can just call, say, a. So you can write that a is your function that takes x as input, and its output is going to be the diagonal, this 5 by 5 matrix, right? So then you can calculate a of, I don't know, 5, a of negative 3.4. So every time a is a function whose input is a scalar and whose output is a 5 by 5 matrix. And then you can write arrayfun like this. So you take x as input, and the output is going to be the determinant of a of x. And then you can apply it to the vector t. Or you can apply it to the vector v. It's the same thing. All right, I hope it's clear, but it becomes even more useful if your function cannot be even expressed as a single complicated expression that involves creating matrices. So here is an example, right? So let me, maybe, can you look at the left of this? Suppose that I want to introduce a function that is called mega function. Yeah, so here is on the left, you see the code for this mega function. So what it does, its entry is a real number, then it calculates the floor function, then it creates the n by n matrix of ones, and then it is going to change some values of that matrix, and then it's going to take its maximum eigenvalue, right? So this, maybe let me write that x, just to illustrate my point. If x is 5.6, then the floor function of x is going to be, the absolute value of the floor function of x is going to be 5, right? So then I'm going to create a matrix 5 by 5. Then I'm going to change its entries on the diagonal to 1, 2, 3, 4, 5, and so on. Then I'm going to change just this entry to x, just the entry in the last column, first row. And then I'm going to calculate the maximum of the eigenvalue of x, the largest eigenvalue of x. And that's going to be the answer. So this mega function does this. So if I put it in a separate MATLAB script, I can calculate mega function of any number, I don't know, 9.5, whatever, I don't know, minus 8, whatever you want. My point being is that it is a very complicated function, and in a situation when you need to apply this function to every entry of a certain vector, you have to use the arrayfun, because if you just write it like this, mega function of a vector, say t, then it's not going to work. Or v, it's not going to work. So instead, you will have to do arrayfun. Arrayfun of, say, function of x, mega function of x. And let me close this. Let me make it bigger. Mega function of x. And I'm going to apply it to each entry of the vector v.